In the following example, let's take a look at a use case within SolidWorks that begins at the enterprise level relating to both project or issue management. From the web client within one of the selectable dashboards, the designer can browse their documents based on a multitude of parameters. In this first case, the designer is interested in documents that may need to be edited based on the relationship to a specific project. Here, the designer selects directly on the graphic to query for all documents that they are a resource for within the selected project. The subsequent document is listed, and the designer may now select the document and open SolidWorks into session with the selected design. As an alternative, let's look at another dashboard that would give the designer access to documents in the context of the issues that need to be addressed within the enterprise. Much like documents, the Issues dashboard organizes data in a graphical way for quick sorting and selection by the designer. We can see that issues are organized graphically based on a number of parameters such as priority, state, problem type, etc. Graphically selecting the most important issues takes the designer to a query of the specific issues or issue where the details may be reviewed. Included in the details of this issue is a revision of a particular design that the issue is reported against, which the designer may now select as before and open up into SolidWorks. This particular issue requires that the designer changes the length of the jaws on this tool to improve its usability. To do this, they must check out the appropriate components within the assembly and make a new revision of the design. Within the document management tree, we can see the structure and status as known by the system in real time. From here, the designer can check out the required components of the assembly for change. Upon executing a checkout, the system scans the status of the existing assembly to allow the user to select the components that need to be modified. This checkout operation will lock the components, preventing other users from making changes to them during modification. The user can now select the arm and open it locally into the session, directly from the integration to make the necessary changes. For this scenario, they will make a quick change to the base sketch that drives the length of this component. Note that the integration to the system allows the user to quickly move between the management and editing of the design during the session. With the change to the design complete, the designer closes and saves the ARM component. Rebuilding the assembly captures this update at the assembly level. Now the designer can check in the completed assembly to capture the changes in a new iteration of the design. The designer now chooses to check in this new iteration of the design into the PLM system. A confirmation screen is displayed showing what will be involved in the transaction. Note that only the two components will be checked in with the check-in of the assembly, as no other changes were made in the structure. The designer chooses to add a comment regarding the specific changes they made during the session for future reference. Once complete, the transaction is executed and the changed components are uploaded to the central server in the PLM system. Once the upload of the data completes, the components that were checked out are unlocked for access by other users globally. The document management tree to the right has been updated to reflect the new status of the assembly. The designer then realizes that the related assembly drawing will not be valid and must be updated as well. The assembly drawing is then opened into session. Once open, the document management tree updates to reflect the current status as well as the relationship to the assembly previously opened. Note that the drawing has not been checked out and remains in a read-only state as noted at the top of the screen. This is reflected in the status shown in the document management tree as well in the preview in the lower right corner. The designer then rebuilds the assembly to update the drawing. Once completed, the designer realizes that they have forgotten to check out the design to capture these changes. The integration to the PLM system allows the user to capture these changes by retaining them during a subsequent checkout operation, avoiding loss of work. The confirmation screen for the checkout transaction notes the relationship between the drawing and the assembly, along with the fact that only the drawing will be checked out from the server, as all other components in session were not edited. The drawing is now open and the session is editable. The designer now chooses to rebuild the drawing again to confirm the update from the assembly. Any other changes could also now be made. Once satisfied, the designer can now check in the completed drawing to the PLM system. The confirmation screen indicates that only the drawing will be checked in, as no other components in the related structure were checked out for edit. Subsequently, the check-in transaction is executed to create a new iteration of the drawing. With the design and drawing now complete and available for others to access, the designer now decides to promote the data to the next state for review. One of the fundamental functions of the lifecycle states is to control who can access specific data and how they can manipulate it. Since the designer is promoting from the drawing, the system attempts to promote the related assembly and subcomponents as well. Once the promote operation completes, the design data is moved to the state Design Frozen, which will make it available for review by a broader group of enterprise users. The designer now wishes to execute some PLM-specific functionality. To do this, the web client for the 3DEXPERIENCE platform must be accessed. This can be done at any time directly from the SolidWorks environment. The web client now exposes information about the specific assembly and components within the PLM system. We can see that property information as well as imagery has been captured during the check-in process from SolidWorks, and note that the structure of the assembly is also known by the PLM system. Returning to a summary view of the assembly, the designer selects the related instances. Instances represent the configurations that are stored within the SolidWorks file. Here we see that there were two configurations and that the second one, highlighted, was active when the assembly was checked in. The designer now chooses to open the active configuration. Note that the configurations within SolidWorks are where the structure of specific assemblies are stored. The file out simply manages the configurations. Note that the drawing associated with this configuration is attached for reference. For this example, a bill of materials was created automatically during the promotion of the lifecycle state of the design. Since the configuration contains the intelligence of the structure, we can see here under the related parts the relationship between the CAD specification and each engineering part. Once we enter the engineering part, we can proceed into the related bill of materials and see the structure that was created to mimic the structure created by the designer, resulting in an engineering-specific bill of materials. From here, the BOM can be further developed for manufacturing. In closing, we can return to the engineering part as one might do outside of the design department and quickly look through the related CAD specification to see the design that supports it, giving us a bidirectional visibility for all stakeholders involved in the design.